Okay, so continuing with volume, if we look at what maybe you have seen in the past. So if we look at this one right here, when we're finding volume of this, I am pretty sure what you guys would tell me, because again, I've taught this in the past, is you would just say, well, it's maybe not base, length times width times height, which means you would take 4 times 10 times 3, and you guys are like, well, sweet, that's awesome. But what I need you guys to look at here is that's totally right, but I want you to look at why, so that we can apply this kind of like we did with the cylinder. So if I get rid of this, what did we do with the cylinder? The cylinder, we said, let's find the area of that CD, which was on the bottom. So if we take a look here, this time it's not a circle. What shape is that on as the base? Well, it ends up being a rectangle, and we know how to find the area of that base. I'm going to call this area of base. So if we find the area of that base and then times it by however many of those rectangles would fit, kind of like the CDs, however many of those rectangles would fit going up that side. And so we're going to take the area of that base and we are going to times it by the height, because that's how tall this is. Now, if you look at that, that's essentially what you guys were doing before, is that you would take 10 times 3, which is the area of this, because we know how to take area of the base. It'd be 10 times 3, and that's the area of that rectangle down there. And then how many of those rectangles will fit? We'll times that by 4. And so we're getting the same answer, but I just want you to pay attention to, that's what we're doing, is we're taking the area of this, just like with the circle, times however many would fit in there. So we would get 12 times 10, so it's 120 inches cubed. Just like you would get if you did length times width times height. But what I want to look at here is, oops, don't want that guy yet. I want to take this right here, because this time on this one, this is actually a triangular prism. The triangles are our bases, not this down here. This is not my base, because the thing is that can't be my base because I don't have another one that's parallel to it. So this time when we talk about our area of the base times the height, we're not talking about a rectangle or a square. We actually are talking about the area of these two triangles. These are our bases. These are the ones that are parallel to each other that we need to call our base. And so we're going to actually have the same formula here. We're going to say area of the base and then times it by the height. How many will fit in there? But we have to just know that, hey, these are my base. So how do you find the area of a triangle? You take half times your base times your height, and then times the height. And so this gets a little bit confusing to some people because they're like, well, there's a height there and there's a height there. Well, that's why we need to just distinguish this is the height of the prism. Okay? We're taking the area of the base times the height of the prism. So in this case, let me grab another color here. We would take 7 times 24 and then times that by a half, or divide by 2, because that is our base times height of the triangle, but we need half of it because of our formula over here. And then we're going to times it by the height of our prism, which is 22. But really what I want you focusing on here is that we are doing the same thing as we did with the cylinder, as we did with the rectangular prism. We're going to take the area of the base and times it by the height. The tricky thing is can you find which one have the parallel sides to it? So if I grab a calculator just really quick here, I can get rid of those, call that 12. We are taking 7 times 12 times 22, and we're getting 1848 meters cubed by taking the area of the base times the height. Now, question that always gets asked is, well, Mrs. Fong, how'd you know that this one up here was the base? Well, it turns out on a cube or on a rectangular prism, it actually doesn't matter. We could have done this right-hand side as my base, but what would you have gotten for the area of the base? You would have taken 3 times 4 and then times by the height between them, and it would have been 10, and hey, we're getting the same answer over there. So the tricky ones are going to be the triangular prisms. When we get into them, the pentagonal prisms. Okay, so we're just taking, to find the volume of any prism or cylinder, we're taking area of the base times the height. Okay, so go try those problems. Let me know what questions you have.